So let's take a look at some more interesting types. We've only seen numbers so far. Let's take a look at text data. So I can represent some text in Python by using quotes. So for example, I just want to represent the letter A. I can put single quotes around it, and that gives me a string. A string is a sequence of one or more or 0 or more characters, actually. Here's a word. I can put double quotes around it. I could put single quotes around it too. I have my choice. There's no functional difference between using single quotes and double quotes, although sometimes one is preferable. And I'll talk about that in a second. So I can write a full sentence with spaces. There it is. Notice in Python there's no actual difference between a character, a single character, and a full string of words. These are two things of the same type. Okay, I can write this 12.0. To us that looks like a number, but if I put quotes around it, Python treats it as a string, a bit of text. Text can be of any length, and like I say, I can write it with single quotes or double quotes. Now, to kind of show you how simple Python can be sometimes, suppose I want to just concatenate two strings. So I have a string 1 which says hello, and string 2 which says world, and let's put a space at the end of hello. Okay, or let's not actually, let's remove that. I've just got hello and world. I add these two strings together. What do you think that means? It means concatenate. So if I do s1 plus s2, it gives me the new string hello world. Of course, I wanted a space between those two words, so I put a space character. I do that with just single quotes and then space. You could also do double quotes and space. And then I get hello world back. All right, so what do you think s1 times 3 does? It replicates that word 3 times. So I get hello, hello, hello. And so you can do this 300 times, you get hello 300 times, and so forth. So there's a lot of stuff that you'd want to do with strings. For example, maybe I want to take a string, like data science is cool, and I want to make it into a title case it, for example. That means make the first letter of every word uppercase. So how would I do that? Well, Python, remember it comes with batteries included, gives you functions for doing all of these things, except these functions are a little bit special. They're called methods. So let's take a look. So I have my string I'm going to write here. Data science is super cool. One of the things I might want to do is turn all of the letters in this to their uppercase versions. Now, I can do that by taking the string name, or the variable name, my cool string, writing dot, and then writing the name of the function that I want to run on that string. So in this case, I write dot upper, I run it, and I get that string back in all uppercase letters. Whenever a function is sort of attached to a variable like this, in this case I have upper, the function upper attached to this variable, we call that function a method. And in this case, I have the string method upper. Notice that function has no arguments. In some sense, you can think of its only argument as being the string that I'm calling this function on. Some methods, however, do have arguments. So for example, the replace method, as the name implies, takes two arguments. One of them is the pattern to look for. What do you want to replace? And the second argument is, what do you want to replace it with? So for example, I take the string, data science is super cool. I want to replace the word super, and I want to replace it with super duper. So writing that bit of code evaluates to data science is super duper cool. One thing I'll point out here, you'll notice I ran this cell that stored this value in my cool string. Then I ran this cell, it made it uppercase. And now if I print out here the value of the string, it's still the lowercase version. Okay? If I wanted to store the result of this, if I wanted to save the result, I would have to write something like this. Okay, and now when I print it out, I see the uppercase version. Okay, so remember, methods don't change the value of the object, in the case of strings at least. And if I want to store the result, or if I want to save it, I have to write an assignment statement as before. Now, mathematically, this might look kind of interesting. This is something that's often confusing to beginners. Suppose I write x equals 3, and then x equals x plus 1, and then I print out x. Mathematically, this here makes no sense. What does it mean for a number to equal itself plus 1? That can't happen. What this is not mathematical equality. This is the assignment operator. It's saying take the value of this thing and put it in here. So if I run this, what I expect to find is 3, and then I add 3 and 1, and I get 4, and so the result will be 4. Okay, so let's see. I started this slide talking about making something title case. Let's try it out. So if I write a variable name here like this, and I write dot, I can see all of the methods that it has. So remember, a method is just a function that's applied to this variable. This variable is a string, so all of these functions here are things I can do with strings. Looking through them, I see a bunch of interesting functions, but this is the one I want. I want title. If I just call it like this, nothing's going to happen. It's going to give me something like this. It says function string title. What Python is telling me is that this is a function that I have not evaluated. If I want to evaluate it, meaning give me a result, apply it to that string, I write the parentheses like this, and I get data science is super cool, but in title case. So I mentioned that there's no real difference between single quotes and double quotes, but sometimes one is more useful than the other, and here's an example of where. So suppose I want to create the string, the bit of text, my string's full of apostrophes. And so I have an apostrophe here, right? My string's full of apostrophes. How do I include that in my full string? Well, if I write this with single quotes, and I use a single quote for the apostrophe, and I run this, Python's gonna get angry at me. It says invalid syntax. That's because Python thinks that I started the string here with the single quote, wrote my string, and then I ended it here with the single quote, and now I'm starting something else. I'm writing some more code. And here it says, I don't understand what you're doing, because the string stopped here, but you're still writing stuff, and I don't understand. Instead, what I can do is, instead of writing single quotes to delineate the string, I can use double quotes, and then put the single quote inside for the apostrophe. Now I get a string that has a single quote inside of it. There's another way of doing it. If I want to escape the apostrophe, that means don't treat this as a normal apostrophe that would delineate a string. Treat it as like a literal apostrophe that should go into the string. I can do that. I put a backslash in front of it. So here I have a backslash in front of it. Notice I have single quotes here. I run the cell. I see a version of it which has the backslash still in the string. This is like the raw representation of the string. If I wanted to see the formatted version of the string without the backslash in it, I could print the string. If I do that, I get a string with a single quote here. And what's nice is I have, you'll notice that I use single quotes out here because I have double quotes here. Okay, so you can use single quotes or double quotes roughly interchangeably, but sometimes it's more useful to use one or the other if your string contains apostrophes or double quotes. So as I mentioned, whenever you display a value in a Jupyter notebook, you see the raw value, you see the raw string. Print displays the human readable version of a string or anything that you give it. So you can also use print, as I mentioned before, to show multiple values within a cell. In this case, I have 12, I have 23. 12 will not be displayed, only 23, because 23 is the last expression. It's the last value in the cell. If I wanted to print both, I could use the print function. So I'd print 12 and 23. Here's an example of a string. It has a special character in it. This \n is a special character. What that character is a new line. So if I evaluate the string, it shows up in the Jupyter Notebook as a raw string with the special character inside. But if I print it, notice that I see 2 lines. The new line character gave me an extra line. In fact, you can add some more in here, get some more lines. Okay, more spacing. So print formats the text nicely and displays it to the user. Just evaluating the cell and showing the string just gives me the raw version of the string. You'll notice too that the quotes disappeared. So there were quotes around this. That was Python's way of telling me that this was a string. But whenever I print it, I don't need the quotes. I'm just printing the value of the string. So we can do type conversion to and from strings, just as we did with ints and floats. Now, this causes some messy issues. As I mentioned before, Excel likes to be really helpful and convert something that looks like a date to a date. So here was the actual data. March 1 is a shorthand for membrane-associated ring CH type finger 1, but Excel interprets March 1 as the date, 1st of March, and so it converts it to 1-mar. So if you look through all of these appendices of all these scientific papers, you'll see instances of like 1-mar where it meant March 1st. So another instance, you'll look through the appendix, you'll see something like 2.31 E plus 13. This was Excel converting this identifier to scientific notation, or interpreting it as scientific notation, and so forth. So the lesson here is that, one, we don't want our programming tool to infer the types for us. We have to make those choices. But the second is that we have to carefully make those choices because we're capable of making the wrong choice as well. Suppose, for instance, we have data that looks like this. So I have a table. It contains various columns of information. So I have the person's name, their address, the city that they live in, the state, their zip code, and their phone number. Okay, so far we've talked about 3 data types: int, float, and string. String is the 3rd data type. It seems pretty obvious that somebody's name should be represented as a string, and in fact we can't represent John as an integer, as a float. Address should also be string. City, string. State should be string. Now when we get to zip code, we see something a little strange here. We've represented the zip code as an integer because American zip codes are 5-digit numbers. So for example, campus is, well, I forget, but San Diego is like 921 and so forth. Here it's converted, or the zip code is 4402. It's only 4 digits when we'd expect there to be 5 digits. In fact, the zip code of Bangor, Maine is 04402. And so whenever we display a number with a leading 0 in Python, it omits the leading 0. The phone number here, we look at it, it's got a decimal point at the end. Phone numbers can't have decimal points, right? That's because we've represented the phone number as a floating point number. So the thing here is that a zip code is a number in some sense. It's a 5-digit number, but we never treat it like a number. Think about this. Do we ever add 2 zip codes together? Do we ever divide zip codes and so forth? No. We never treat a zip code as if it is actually a number. So in that sense, maybe it makes more sense to store it not as a number, but as a string. Same with a phone number. We don't add 2 phone numbers together. We should treat a phone number as well as a string. And if we do that, we get all the benefits of treating them as strings and none of the downfalls of treating them as integers. For example, 04402 being displayed as 4402. If we were to store that zip code as a string, we would see 04402. So if I want to convert a number to a string, I can use the string function, just as I used the int and the float functions before. So here I've got the integer 3. I want to convert it to a string. That's how you do it. Okay. Suppose I want to go the other direction. I've read some data in off of a website. This is something that data scientists do a lot. They download a website and scrape it for information. While that website is just one big string. It's written in HTML. I need to convert some of those strings to numbers. Okay, maybe I'm reading the temperature of the ocean in La Jolla, so I know whether or not it's warm enough to go out surfing. I read that, I get a bunch of text. I need to convert that to a string. Well, in Python, it's very easy. If I want to convert that string to a number. If I get the string 3, I can convert it to a floating point number by writing float and then the value that I want to convert. And so it just takes that string and converts it to 3.0. Same if I want to convert 4, the string 4, to an integer, the integer 4. There we go. Before I move on, let's show a couple of times when things can go wrong here. Suppose I want to convert 4.5, the string 4.5, to an integer. I run this cell. I get an angry message from Python. It says value error, invalid literal for int with base 10. What it's telling me is that the string 4.5 cannot be interpreted as an integer. Okay, remember I can convert int of 4.5 to 4. Okay, and Python's happy to do that, but doing this would basically be converting a string to a float and then a float to an integer. That's too many steps for Python, and it says if you want to do this, you're going to have to do it yourself. The way we do it is write float of 4.5 and then take the int of that. So this is our first instance of sort of nesting function calls. If you're not comfortable with it, you can do something like this. X equals the float version of 4.5 will give me the int version of x. It's 4. Okay. Now I'll briefly show you a little bit about sequences, lists, and arrays, but we're going to focus on that more next time. So as a data scientist, we're not usually working with single numbers and single strings. We're working with massive amounts of data, usually sequences, lists of a bunch of numbers. And so Python gives us data types for working with those. One of them is a list. So a list is just a container of objects, a container of items. It can hold integers, floats, strings, any combination of them, and even more complex types that we haven't learned about yet. So I can make a sequence in Python by writing square brackets. So this is a list with 5 so-called elements, 1, 2, 3, 4, and 5. And if I evaluate it, I basically get the same thing that I wrote back. Now it can contain numbers and strings at the same time. So it can have a list can be heterogeneous is the word that we use in terms of the data types they contain. The thing with lists in Python is they're very useful, of course, but they're slow. And as data scientists, we want to write fast code because we're working with really large data sets. And so there's an extension to Python called NumPy. It's a third-party extension that people have worked on for a decade, if not 2 decades, to make really fast versions of lists called arrays. And so we'll see more about arrays next time, and we'll work with arrays throughout the quarter. But the idea is that they'll be very fast and enable us to do data analysis very quickly. So I'm going to stop there for today. Your homework doesn't get quite up to arrays, so we'll leave that for next week. I want to point out, though, this lecture, in my opinion, is the most boring lecture in this quarter, and that's because we're working just with basic Python stuff. In the next lectures, we're going to get into real data analysis and look at real data sets, and I think stuff will get much more interesting from here on out. Okay, I'm going to show you in the next video how to upload your homework, but that's it for this lecture.